My name is Manfred Helber and I'm a Microsoft Most Valuable Professional in the category Cloud and Data Center. This session will be a complete full live demo about how to deploy the 4-node configuration for Azure Stack HCI. Let's switch to the live demo environment, and in Windows Admin Center, as we have seen in the two previous videos, we choose Add to create a new Azure Stack HCI cluster. This new cluster is an Azure Stack HCI cluster, and in this deployment, all servers are in one site. Keep in mind, 4 nodes is the minimal configuration where a stretch cluster with servers in 2 sites would be possible. I will select Azure Stack HCI deployment, all servers in one site. Let's create or start creating the cluster. In the first step, we click on Next. Here we have our credentials and we have to specify the names of the servers. I have a D102, this is my demo environment, minus Azure Stack HCI, and the node is 41. And for sure there's a node 42, 43, 44. I will add all these nodes, and as you can imagine, compared to the 2-node cluster and compared to the 3-node cluster, it takes a little bit longer to add all these nodes, to validate the nodes, because as I mentioned in the 2 previous videos about deploying Azure Stack HCI, this is great about this wizard here, that all the steps are validated, so I always can see if there are issues, if there are other recommendations. It's not only about misconfigurations, it's also about recommendations here. And as we can see here, actually I can see, oh, maybe this is another manufacturer. There's Windows Admin Center a little bit too early to provide this information, because actually Windows Admin Center does not know about the node 3, what the exact configuration is. So I would change this. If I would be the developer, I would wait till all the nodes are verified, and then I have a final result. We will see that this message here will disappear when the Windows Admin Center realizes, oh yes, these are 4 identical nodes, because as I mentioned in the 2 previous modules, I am using virtual machines here for this deployment, and this means that I have Microsoft Corporate Virtual Machine as the model, and the operating system is Azure Stack HCI on these nodes. What you will see in this demo compared to the 2 previous live demos, as more nodes you have, as longer it takes to go through this wizard. We have sometimes different options, and for sure we have more time to wait till the machines are joined to the domain. I already prepared this here, till the features are installed. Here you can see I already pre-installed Hyper-V on the nodes. Why did I pre-install Hyper-V? When you review the 2 previous modules, I mentioned, and we have seen this issue here, that actually the deployment wizard for Azure Stack HCI in Windows Admin Center is not able to deploy Hyper-V in a nested virtualization. It always runs into an error. If you have this situation, you can manually install Hyper-V on this machine, so it's no problem. I prepared this here because when we would do it for 4 nodes, we would spend a lot of time in this video to do it. So let's install the rest of the features. And here you can see again how great this is. We have 4 nodes. Let's imagine we have 60 nodes in the maximum. By the way, it's not recommended to build one big 60 nodes cluster. We would usually prefer to have 2 8-node or 4 4-node clusters, because also in a 16-node cluster, we have the situation that we can only survive 2 simultaneous failures regarding the volumes. The storage spaces direct pool keeps up and running if a maximum 50% of the servers fail. The cluster can remain online till the last node, so 15 nodes could fail. But regarding the volume, so there we have to focus on the resiliency level, and the maximum resiliency level is three-way mirror, so we can survive 2 independent storage failures on 2 different hosts, and this is the same in a 16-node cluster, except we have a stretch cluster configuration. In a stretch cluster configuration, we can also survive more storage failures, but there we have a more complex configuration, and we wouldn't build a stretch cluster if we don't really need it for our configuration. So now here we can see all the required features are installed, and we can go to the next step. So I will click on next to see if there are updates. Like in the 2 previous videos, I will not install any updates here because we have a dedicated module where we will speak about update management for Azure Stack HCI, and there we'll install the updates. In a production environment, you would take the time, install the updates here. If you have an integrated system, also install the hardware updates. I have no integrated system and I have virtual machines, so there are no driver updates. So I can go to next, and usually the servers will require a restart at this point of time. So I assume I've never seen an installation where it was not required to restart the servers here, but it's again an easy process. I only click on restart servers, and these 4 servers I plan for my Azure Stack HCI cluster will be restarted remotely. I don't have to connect to these machines. I don't have to trigger a restart manually. It's done automatically, and it restarts the server, and then it checks the availability. So again, when the servers are back up and running, I have the situation that I can be sure the servers are reachable, and I can continue with the next step with the host networking. And I explained this in the 2 previous videos about deployment of Azure Stack HCI. There are 2 different ways to deploy the host networking. One is to use the network ATC. It's an intent-based configuration. We're working with something like templates. So it's great if we have reoccurring network configurations, if we plan to add nodes with a complex network configuration at a later point of time to understand what happens in the configuration. In my opinion, it's better to run the manual configuration, and we will choose for this in the network step, and then we can create the virtual switches and the virtual networks in the part 2 in the networking section here. So all servers are ready, and I can proceed with the next step. So let's click on next, and I will configure manually the host networking. And then in the next step, the networking settings, the interfaces will be validated. I can see here refresh, then they will be validated again. I can enable interfaces if they are disabled. I can disable interfaces if I don't want to use them. I can include interfaces or exclude interfaces if there are interfaces in my server I don't want to be part of this Azure Stack HCI deployment here. The validation helps us to see which interfaces are in the server and how they are actually configured. We need this information from the validation in the next steps, because there we will see we get exact details about the network interface cards, the IP address configurations, and even the MAC addresses. So the verification of the network interface cards has finished. As I mentioned, you can see here the configuration of the cards, details including MAC addresses, and the status. I will proceed with the next step, and I will select the management adapter. The management adapter is for the host operating system, and we have the option to team a network adapter or to provide a switch embedded team for the management OS. I will use one dedicated adapter. I should select exactly one, and the 2 highlighted, so the first one or the last one, they are usable for the management network because they have access to our domain network. So first is to specify this management adapter. Then I will apply and test these settings, and it's again apply and test. It applies the changes and tests the settings. Yeah, the management adapter has been configured and validated, and in our next step, we will decide for the virtual switch. There are different models for the virtual switch, similar to the 2 and the 3 node configuration. In a 2 and 3 node configuration, it's a very good option to work switchless. It's perfectly in the 2 node option. It's possible in the 3 node option. It's also possible in the 4 node option, but you need a lot of cables. So as more nodes you have, as more it makes sense to have a switched connectivity for the storage network. The storage network is this one here. This is the storage traffic. This here is the storage traffic, or this here is the storage traffic. When I say switch, I mean a physical switch for the physical adapters here. We can see in the scenarios, in the first scenario, we're using a switch embedded team that brings together all the physical interfaces to one set switch, and on the logical layer, it divides into storage and virtual machine traffic. In the second option, we will have one switch embedded teaming switch for virtual machines, and we only use SMB multi-channeling. It's a perfect option. We don't have any disadvantage regarding the throughput or things like this, and we don't need to configure the switch embedded teaming switch. In the third option, we have two set switches. They are independent, one for virtual machine traffic and one for the storage traffic. It depends on your scenario which is the best option for you. I implement in many scenarios the second one because I'm sure, I can be safely sure that I have two dedicated or more dedicated adapters, minimum two dedicated adapters on the physical layer for storage traffic, and the rest I'm using for the virtual machine traffic. It depends on your scenario. I will skip the virtual switch creation here because we can create virtual switches later in the Windows Admin Center. RDMA is strongly recommended for production environment. Please review and refer to the video about Azure Stack HCI hardware requirements to learn more about the RDMA capability here. And in the next step, I will define networks. And here we can see it's again a lot of work to enter all these values here, but it's really great to have this table because I have one central location where I can specify the names and decide, okay, this should be here SMB1, the next one is SMB2, and this on each server here. And to see on one page if everything is configured accordingly, if all the settings are identical on the servers. This one will be my virtual machine network. This one will also be my virtual machine network here. And for sure, I also will configure the IP addresses. I mentioned this in one of the previous videos. It's not very comfortable to work here with only the keyboard, with the tab key and things like this. So you usually will need some mouse clicks to activate this field here. This is in the actual version of this wizard, the situation, but all over it eases the deployment enormously. And if you would use a script alternatively, because for sure this is also possible to do this all via PowerShell, then you would have to enter all this information in your PowerShell script. Here I have this great table, and I will specify an IP address. It's the 101.11 here. And don't wonder, I used exactly this IP address in some previous videos, but I have separated this SMB networks here on the switch layer. So I'm using always these addresses 11, 12, and here the 21 and 22 to have the same or similar configuration to ease the videos here and the way how I do it. and we will not have an IP address conflict here because I have dedicated switches. In the physical world, this would mean a separation based on the VLANs or a separation on the physical layer via cabling and switch ports. Here I'm using virtual machines. I mentioned this several times, and I'm using the dedicated virtual switch for these machines here. So now you can see I'm at the host number 3, and the wizard always checks if this is possible. Here I can see this is an invalid IP address. Yes, I know this. I'm actually still typing. But if you have a typo in there, this is a good thing that you are informed there, sometimes a little bit too early because you are still in the work. And then please be not, don't be hesitated here because of this information here. It will be removed as soon as I type my IP address to the end. So, okay. I have to specify the subnet mask. This is the last part. I have to have my preferred subnet mask here for each of these interfaces here. And we have again the validation if this matches, if this is fine so far. And we will also see the changes pending at the end of the line. And we will save a lot of time compared to manually configuring the hosts. For sure, it would be great to have some import file here where we could use a pre-configuration. As you know, these features always develop in Windows Admin Center, and when you compare it to the first version where you had to do this in very many manual steps, it's really great how it works actually, and I like it to use this wizard-based deployment. So it can happen that there's an issue, even especially when I have so many nodes. And so I have again this apply and test button here. So the settings are not only applied, because then I don't see if there are errors in there. I also have the validation of the changes. And if everything goes fine, if everything is okay, then we have the situation that it's green at the end of the line. Please don't wonder if some of the lines are green and then they are testing again the changes, because here, for example, we can see, oh, here the changes are applied, but then when they are applied on all the adapters, the changes are tested. This is the next step. So now they are testing. So don't be afraid because these green signs are now removed. And now the test step runs, and when the test has finished, then I can see if everything is configured correctly or if I have some issues here. So all the tests have been passed. This is perfect. And so I can proceed with the next step, clustering here. So the next step is clustering, checking a few things in this step. And in this step, we will see the validation of the cluster. So the pre-check has finished, and now I can validate the cluster configuration for this 4-node cluster. And for sure, this will need some additional minutes compared to the 2-node or the 3-node cluster, because every node is validated, the hardware configuration is validated, the disks are validated, the networks are validated, and we have an additional disk validation in the storage step number 4. So give this wizard some time to gather information about nodes, to validate the nodes, and then in the final step to show the result. So depending on your configuration, it will even need a little bit more time if you have very complex nodes with many network adapters, with many different devices in there, because this will be part of the validation. It's important to keep in mind that the cluster is supported if we have an Azure Stack HCI certified solution and the validation is successful. It would be also supported if we have only a successful validation, but my recommendation is absolutely to use a validated Azure Stack HCI node configuration or integrated systems We discussed this difference in the hardware requirements. The validated nodes for Azure Stack HCI have all the validation tests passed, and so they are perfectly for running Azure Stack HCI on them. You can see gathering data about nodes, 86%. It's not a linear bar here, not a linear process bar. So we will see that this jumps to 100% at the end, and then we can continue with the cluster validation and configuration. When the report has been generated, I should review first the overview here. Inventory is fine, network is also fine. I have a warning in the system configuration, and here I can see a warning I will receive often. I have different software update levels. So I have some updates on one server I don't have on the other servers. I can download the report here to see some details about the configuration. I will check the report and open the file. And here I can jump to this system configuration setting, validate software update level. And here I can see that not all nodes have the same version of operating system updates and software updates. So when I scroll down, I can check exactly, sorry, I have to scroll up. I can check exactly which update is differing or different. And I can see here I have some differences in the Defender update level. This will happen very often because Defender is updated on a regular time, and maybe I restarted one server once oftener than the rest. So for me, this is fine. Usually you will not see this when you installed updates in the first step getting started, because then the nodes should all be on the same level. I will proceed with the next step and create the cluster. In my configuration, I'm using dynamic IP addresses. This means I do not need to enter any cluster IP address. In a production environment, I would prefer fixed IP addresses and or IP address reservations in the DHCP server. My name for the cluster is Azure Stack HCI Cluster 40. We have 3 of them. The cluster 20 is the 2 node, the 30 is the 3 node, and the 40 is here our 4 node cluster we are actually creating. Here in advanced, we can decide if all the storage drives should be added to this cluster. This is important in the next step where we decide for the drives, and we can here specify networks that should not be part of the cluster. I will leave the default values and create the cluster in this step, and then continue with the storage part. Now the cluster service is configured on each of the nodes. The cluster is formed. I can see the progress bar here on the screen, and for sure I can also see the progress bar in the notifications area here. We have a verification of the cluster name and the DNS name resolution. And when the cluster is completely built, I will have the option to download a report again to see if everything worked, if everything is okay there. So the cluster is created, the cluster name DNS resolution is working, this looks good. And now I get the information that I should create a cluster witness. And in this video, we will see how to create a cloud-based witness. The 2 previous deployment videos, we used a file share witness. Both is possible. So here we will see as an example how to configure a cloud-based witness. Next is the storage configuration. I want to erase all the drives. This is a good idea to do this if you are reusing the systems, if you already tested storage spaces direct on them. So it was successfully, all the drives were erased. Here I can see the drive check. All the drives in my systems are poolable. This means they can be used for the storage spaces direct pool. All the drives are okay. I can see the slot. I can see the firmware. The firmware is important because the firmware is relevant if the drive is supported for storage spaces direct or not. Then the storage is validated. Again, one of these very helpful validation steps we have seen several times here. In the previous steps, validation networking, validating the cluster, now validating the storage, the drives, if they are poolable. And as you can already see, the last step is then enable storage spaces direct. So this is the final step to activate the storage spaces direct configuration. Here I see detailed information about my drive situation, and I can download a report where I can see if everything was claimed successful, if my drives are suitable for storage spaces direct, and if it's a good idea to proceed with the enable storage spaces direct. If there's a failure with the drives, we cannot enable storage spaces direct. So, but you should review the report and save the report to be sure that everything works correctly. Now storage spaces direct is enabled. This is the final step here, starting the health providers, the storage in storage spaces direct. The pool will be formed, the disks will be claimed by the pool, and we will have a first volume called cluster performance history, which provides the historical data for our Azure Stack HCI cluster. We have seen this in some previous videos. In the Windows Admin Center, we can not only see the actual situation on the cluster, we can also see some historical values there if they are stored to the cluster performance history. And this is the default behavior here, this configuration. So, and again, we can see with this 4 nodes, we will need some more time than with 2 or 3 nodes, because we have to add more disks to the pool. And so we have to build additional storage layers. We will see this when we are creating and managing volumes with Windows Admin Center later in this video series. There we will see there are differences between the 2-node, the 3-node, and the 4-node configuration. We will not use a 5, 6, 7, 8 configuration because the 4-node configuration is the last one compared to 2 and 3 node that adds additional opportunities regarding the resiliency level. If we have a 5, 6, or 7 node cluster, we have additional nodes, we have additional drives, but regarding the possible volume actions, everything is identical to the 4-node cluster. So we have 3 specific situations: 2-node, very specific, 3-node specific, and 4 and more nodes. And this is the reason why we are deploying the 3 clusters. If you reviewed the 2 previous modules, maybe you will say, okay, these are very similar steps, why we are doing this. The 3 scenarios we are focusing on are the typical scenarios customers are using, mainly in the German speaking area, where I'm involved in many Azure Stack HCI cluster scenarios. We very often see 2 nodes, we often see 3 nodes, we also often see 4 nodes. Larger clusters we have sometimes, but the most clusters are between 2 and 4 nodes. And Microsoft has shown some numbers on a Microsoft Ignite a few years ago. It was not for Azure Stack HCI specific because we hadn't Azure Stack HCI in those times. It was about clusters overall. And then we have seen that really also worldwide, most of the clusters are between 2 and 4 nodes. So now it's starting the health providers, and after a few additional minutes, the cluster has been formed. This happened in the step before, and the storage spaces direct has been created, including our storage layers and the storage templates. So storage spaces direct was enabled successful in my Azure Stack HCI cluster, and I can download a final report with the final steps in the configuration, where I can see, okay, there's no cache on the nodes, but this was planned in my configuration. So also this report should be reviewed and saved. In the next step, we could configure software-defined networking. We will not do this in this demonstration, and we can also see it's not possible to configure software-defined networking if there's no external virtual switch, because this is related to each other. So I will skip this step. And here we can see that's all. We are done. Go to the connection list. It may take a few minutes before the cluster to become reachable by name. So this means be patient, spend some additional time, then click to go to the connection list. I can see the cluster already. I can see the nodes involved. And now I can try if I reach the cluster. In the actual version of the Windows Admin Center, I often see the problem or the issue that when I connect first time to a cluster, I only see a short list of tools. It's only with the very first connection to the cluster. If you have the same situation, you say, okay, Azure Monitor updates performance with the rest, then go back to your connection list. You could also refresh the page, but I usually go back to the connection list and open the cluster again. And then usually the rest of the tools is loaded. Yes, the dashboards, the virtual machines, the servers. Servers interesting because now we have the 4-node configuration here. And we will care about the rest of the administrative tasks in additional volumes where we compare the different cluster sets. What we have to do to finalize our configuration is to register this cluster in Azure. It's not yet registered. The next module, number 10, will be about registering Azure Stack HCI in Microsoft Azure and activating Azure Arc. So I strongly recommend you to review this module because this is mandatory. We will see this there in a 2-node configuration. It's the same absolute identical steps for 3 and 4 nodes. What we have to configure in this cluster, we also did this in the 2 previous configurations with 2 and 3 node clusters, we have to configure a witness. A witness is an additional instance that has a vote to ensure that we can build a majority of the cluster nodes, a majority of the cluster votes in the situation of a failure. In a 4-node configuration, the cluster witness has a vote also. So we have 5 votes incomplete. So that this works correctly, it's important that the witness is not part of one of the servers. So it's an independent additional server where we have a file share. We don't need to install any role on this machine. The file share, we only enter it here. We did this in the previous demos. So we have the D102 minus DC01 witness. This would be a possible option. I can show this to you. I save, and this file share is already prepared. The witness status is online. But I mentioned in the 2 previous videos that we will configure a cloud witness here. A cloud witness is not bound to these 4 nodes. We also can use a cloud witness in the 2-node or in the 3-node configuration. A cloud witness needs some additional steps. And to be able to build a cloud witness, we need a storage account name. So I will switch to my Azure subscription page, and I will enter here in the search and storage accounts. I will create a storage account. Okay, let's create a storage account. This storage account will be an account. I will create this one here. It will be in my Azure sponsorship. It will be in the resource group Azure Stack HCI. I have an Azure Stack HCI resource group here. You can see I have several resource groups. Some of them are built automatically. Some of them are built manually. I will use the Azure Stack HCI demo 30, this one here. I could also create a new one, Azure Stack HCI demo 40, so on. I will use this resource group. I will use a storage account name. This is Azure Stack HCI cluster demo. Yeah, this will be in West Europe, Europe West. This is my region. You've seen you can select your preferred region. It's a standard performance. It's not geo-redundant. A typical witness is a non-redundant storage. Azure Stack HCI cluster demo It's the demo 30 resource group. I will preview and create this one. As a review, I will create the storage account. This happens in Azure. The storage account is created. It will need a few minutes to finish. And then I can take the information from the storage account, because you have seen we will need a storage account name and a storage account key. And there's no search button. I have to copy from the Azure portal. I have to pull this from the Azure portal and provide this in the Windows Admin Center. So I will go to the resource here, and I will select the access keys. We have an entry access keys. We have the storage account name. I will copy this storage account name here. It's copied, and I will put this here. This is the name I decided for. And I have the keys. I can show keys here. I can copy the key. I can hide the keys again, and I can put this key in here. And as soon as I do this, I can save it, and the witness settings are saved. The admin center, or no, not the admin center, the nodes try to connect to Azure, and if this is successful, we can see, oh, the witness is online, so it tested this here. The Azure Service Endpoint is optional, and when I come back to this setting here, to the witness settings, I will see now I have the cloud witness. The key is not shown. This is good, because you don't want that somebody pulls it out here. And the Azure Service Endpoint is added automatically. This is the default endpoint. If you need another one, then you have to check the available service endpoints. It's also available in the Azure portal, where you could choose for different one if you have a different configuration. This is my service endpoint for this exact configuration here. So this is the easy steps to a cloud witness. A cloud witness has the advantage if you don't have this independent location. If you say, okay, I don't have an independent server where I can put a file share on. I'm often using a domain controller. My point of view, it's fine. You can discuss a lot about this, if it's good to use a domain controller as a witness or not. The cloud witness is also a great option. What's important, if you are using a cloud witness, you should have an internet connection where you usually don't have any outages, because if the cloud witness is not available, you will have some reduction in possible failover scenarios. A failover will still work, but concretely in this 4-node cluster, you can lose one server without any impact. If you lose 2 servers at the same time, it might happen that you have a downtime when your witness is not reachable. So the witness is important, but the witness itself is not redundant, and the witness can be a file share or a cloud witness.